and you'll try to find a set of critical points if such exist. So let me name it as x0, y0, z0. And if you try to find out what is f of x0, y0, z0, that's basically the maxima or the minima value. So these are the points which can be either a maxima or minima, and when you do f of when you find out the values, when you try to find out the value of the function at that particular point, you'll get the maximum or the minimum value. So yeah, this is essentially the method, and this is all you need to know in order to solve this particular exercise. So I'll probably take the first problem. Okay, I think someone had a set of problems. I'll try to do it from there. She asked 3.4.3. Okay, for the third problem, fourth problem, 17. Okay, let's do 3, 4, and 17 in this. Okay, I'm going to do the first one. I'll do it slowly so that you guys get a hang of it, and then the next problems we can do it a bit fast. So this is the first problem. They're asking us to find out the extrema of a particular function f subjected to given constraints. So the function f is like f of y comma z is x minus y plus z, and then your g of x comma y comma z, which is your constraint function, is given as x squared plus y squared plus z squared minus 2. Okay, so this is your constraint function. You can also have it as equal to 2, like the constant term doesn't really matter here. Okay, so in order to find out the critical points, you need two equations. One is your gradient of f is lambda times gradient of g, and then is your constraint equation, which is your g of x comma y comma z. So we are going to solve for these two equations. We'll get a set of variables, set of unknowns. You'll try solving that and you'll find out the values. So let's first try to find out what is gradient of f. So your gradient of f is going to be a column vector, which is 1, minus 1, and then 1. And just taking this equation and then differentiating with respect to x, y, and z. So I get this column vector is equal to lambda times my gradient of g. So take this equation, differentiate with respect to x, with respect to y, with respect to z. So this is one equation that I get. And the other equation is just x squared plus y squared plus z squared equal to 2. And that's your constraint equation that's already given. Now, if I just equate the matrices, I'm going to get 1 is equal to 2 lambda x, minus 1 is equal to 2 lambda y, and 1 is equal to 2 lambda z. And I have another constraint equation as this. Now, if you just see like, if I just divide this, and this, I can see that my x is equal to z is equal to minus y. So this is one relation I get from these three equations. And I have this particular relation. So if I just substitute my z and y values in terms of x in this constraint equation, I'm going to get some relation. So let me do that. So x squared plus y is like minus x, and then z is again like x squared is equal to 2. So I get like 3x squared is equal to 2, and I get x is equal to plus or minus 2 by root 3. Okay, I get a coordinate of x. So for this particular value of x plus 2 by root 3, let me see what is my y value. My y is minus x. So it's going to be minus 2 by root 3. My z is just x. So this is one critical point. The other one is if I take the negative variant of this, so I'm going to get this. So these are my two critical points that I have. So once you find out the critical points, all that's left is to find out the values of the function f at these points. So let's try to find out that. So my f of 2 by root 3 minus 2 by root 3, comma 2 by root 3. Let's see what do we get. If you just substitute in this equation, I get x minus y plus z. So which is 2 by root 3 plus 2 by root 3 plus 2 by root 3, which is 2 by root 3 plus this. Oh, sorry. Yeah. Which is basically 6 by root 3. Okay. So then the other one that I have is my function f at minus 2 by root 3, 2 by root 3, and then minus 2 by root 3. So I'm going to get this as this can be simplified as well, but this I'm going to get as minus 2 by root 3 minus 2 by root 3 minus 2 by root 3, which is basically minus 6 by root 3. Okay. So as you can see, like this is the maximum value and this is the minimum value. So this point, it is the point of maxima, and this particular point is point of minimum. So all they're asking the question is, what is the extremum values of this particular function? So we have found out the extreme values, which is 6 by root 3 and minus 6 by root 3. And these are the 2 points at which they occur. And yeah, that's all that's there about this method. So this is a pretty, standard or a simple problem where you just have like very nice equations and you can solve. There'll be few questions where there'll be a lot of unknowns, a lot of equations. It's all about, just solving all of the equations to get some relation like this. Then you substitute that in your constraint equation to get some kind of coordinates. So the main step is finding out all these critical points. So once you find that out, you can easily find out which one is the maximum, which one is the minimum, and all that. So in some questions, you'll just get like 1 point. So that point, if you try to find out the value, that value, it might be either a maxima or a minima, which you'll try to figure it out. So yeah, that's basically the method of solving problems of this type. Do you guys have any doubts? I'm going to check the Zoom chat. There's nothing on the Zoom. Okay. Yeah, if you get familiar with this method, you can literally solve any question in this exercise. Yeah, but there are a few questions which I would like to solve. They are like standard questions, and you can pretty much easily expect a question from this exercise in your exam. Some similar question in your exam. Okay, any doubts? Okay. Not. I'm going to check the next one. I think next one, someone had asked for the fourth question. Let's see. 3.4.4. So you have your function f of x comma y is x minus y. And then you have your g of constraint function is x square minus y square equal to 2. So when I try to, do this, I am going to, write the first set of equation, which is the gradient of f is lambda times gradient of g. So let's see what's the gradient of f, which is 1 and minus 1 is equal to lambda times my gradient of g, which is 2x minus 2y. So if I equate both the equations, so I'm going to get 1 is equal to 2 lambda x and minus 1 is equal to 2 lambda y. So minus 1 is equal to minus 2 lambda y. And this I can also write as 1 is equal to 2 lambda x. So if I just compare these two equations, I can see that my x is just replaced with y. So I can see that my x is equal to y. So I get this relation. But let's see what's my constraint equation. So I have to find out the points which actually satisfy this as well as my constraint equation. So my constraint equation is x square minus y square is equal to 2. So when I substitute x equal to y, this relation no longer satisfies. So that means I don't have any, I cannot find any critical points that actually satisfies, both these equations. So no critical points that satisfy this equation. So since I don't have any critical point that satisfies the equation, like I'm gonna say that there are no there is no maxima or minima for this. One second, just give me a moment. Yeah, sorry, I'm back. Do we have any doubts in this question? I'm gonna check this one. Okay, there's nothing on the Zoom. Okay, let me see what was the next question that was asked. It was 3.4.17. Okay, 3.4.17. 3.4.17 is finding out the maximum and minimum values that are attained by a particular function on the unit ball. And they given the equation for that. So you can expect like questions of this type. Like this is like a very standard question where they're asking you to, find out the maximum, minimum values, and they're given you a ball, or it can be a cylinder, it can be a sphere, it can be anything that can be a constraint, and they can give you any function f, which you try to find out the maximum and minimum values for. So this is a very good question. So probably pay attention to this. So let's see what's given. So I have my f of x comma y comma z equal to x y z, and then I have my g of x comma y comma z as x square plus y square plus z square less than or equal to 1. So I've been given these two, and I'm asked they're asking like what are the maximum and minimum values. So yeah, like let's for I can break down this particular condition into two parts. One is case one where my x square plus y square plus z square is less than 1, which is kind of like inside the sphere if you think about it geometrically. So in this case, like what I try to see is I try to find out if the I equate my gradient of the function equal to 0. So let's see what is the gradient of f. Gradient of f will be yz, it will be xz, and then it will be xy. I equate it to 0, which is a 0 vector. So this, I get it as like either yz is equal to 0, xz is equal to 0, and then xy equal to 0. So from this, I can see that, the points can be like, it can be like x00 or y0, or it can be 00z. But, you can see that it's like, when either one of them is like equal to 0, my xyz, my actual function, if you take either of these points, my actual function actually becomes 0. So which is clearly a minimum. So inside the sphere, there's nothing we can, try to optimize or, find out the values, because they're always going to give you a minimum value. So let's basically, take the case where I look at the surface of the sphere, which is x square plus y square plus z square equal to 1. So this is on the surface of the sphere. So this is where we actually probably, apply a proper, Lagrangian multiplier principle. So I have my delta f is lambda times delta g. Let's see what is delta f. So delta f, we already figured it out. It is yz, it is xz, and then xy is equal to lambda times my gradient of g. So g is this. So if you try to find out the gradient, you're going to get 2x, 2y, and 2z. So 2x, 2y, 2z. Okay, so I'm going to get yz is equal to 2 lambda x, xz is equal to 2 lambda y, and then xy is equal to 2 lambda z. So you can see that I'm going to get like the points as like, if I just try to isolate the lambda, so 2 lambda is yz by x. And then this is xz by y is equal to 2 lambda, and then xy by z is equal to 2 lambda. So I basically get yz by x is equal to xz by y is equal to xy by z. So if I take this one, I'm going to get it as xz square is equal to xy square. So I get like, z is equal to z square is equal to y square kind of relation. If I take this, I'll get x square is equal to y square kind of relation. So ultimately x square is equal to y square is equal to z square. So that's one relation that I have. The other one is the constraint, which we know this is the constraint. So x square plus, so from the constraint, x square plus y square plus z square is equal to 1. So since I know x square is equal to y square is equal to z square, I can write this as 3x square is equal to 1. So I get x square is equal to 1 by 3, or x is equal to plus or minus 1 by root 3. So this is like one point. The other points, there's like one coordinate. So if I take x is equal to 1 by root 3, the other points can be anything. So I'm just gonna say the points are like plus or minus 1 by root 3, 1 by root 3, and 1 by root 3. So it can be of any combinations. So these are the set of critical points. Okay. Now with this set, all that I'm trying to find out is which particular coordinate or which combination of these points are going to give me the maximum and minimum values. So it's going to be, pretty, straightforward that if I take all positive values, all positive coordinates, I'm going to get a positive value, because my f function, it's like, a multiplication of three coordinates. So only when all the three are positive, I'm going to get the maximum value. And when all the three are negative, I'm going to get the minimum value, the least value. So I'm going to pick up the point 1 by root 3 where all are positive. I'm going to just multiply all the three because it's x, y, z. So it's going to be 1 by 3 root 3. And then if I take all as negative, I'm going to get it as minus 1 by 3 root 3. So this is the maximum value and this is the minimum value. You can take any of the coordinate as, I can have it as minus 1 here. In that case, like I'll be getting the negative value as well. So so all you need to know is like what is the maximum value, what is the negative value, and I'll be getting this. These are the maximum and minimum values. And for critical points, you can just mention like these are the set of critical points. Okay. Do you guys have any doubts in this question?
I have a question.
Yeah.
So you're saying that as long as x is plus or minus 1 over square root 3, and y and z satisfy the equation to where x squared plus y squared plus z squared equals 1.
Correct.
That's the critical point?
Yeah, correct.
Okay, nice. All right, thank you.
So all we need is, to find out this critical point and then classify this critical point as a maximum minimum point. So the whole point of calling a point as a critical point is because it's going to give you a maximum or a minimum value at that, function at that particular point is going to give you a maximum minimum value. So we are trying to isolate first all those points and then try to find out the values at all each of the points and then figure out whether it's a maximum value or minimum value. That's all. So how to arrive at the critical point is given by this Lagrange multiplier set of equations. So as you can see, you just need to solve like a few sets of equations here and there, get some kind of relation. Once you find out the relation, try to isolate one coordinate. Once you get one coordinate, you can use the relation from all other equations to figure out the other coordinates. So the bulk of the step is here, like, figuring out from here to the point of getting the relation. All of this stuff should be very simple once you find out the critical point. So you can take like 23 also as like one of the examples. Like it's going to be very similar. They are again asking you to do it on a ball, except that your f function is different there. So you can use a similar method to arrive at that answer. 24, they're saying repeat the same thing with another f function. So as you can see, this ball problem, finding out the maximum minimum values, they are a standard, kind of question that you can expect. Like they can give you a constraint equation, they can give you a function that you try to optimize, and then figure out the maximum values. 16 is also very similar. They're given you the constraint equation, that's your plane, and they're given you a point. So they're asking you to find out the distance. So here they're not given the f function explicitly, rather your f function is basically the distance. So given 2 points, you can take any point on the plane as some x, y, z, and then you have another point 2, 0, 1, minus 1. So you try to find out the distance between these 2 points. So it'll be in variable of x, y, and z, and that is your f function. You try to optimize that given this plane equation as the constraint. So you'll get some point, some will be you'll get some distance, and then they're saying like just try to compare this distance with the actual distance of a point from a plane formula, and you should get both of them as the same answer. Okay, that's 16, 17, 23, 24. Yeah, all of the questions in this section are pretty similar, like, except they are just changing the values here and there. But yeah, like if you do 2 or 3 problems, you should get the hang of this. Okay, any doubts in this method? Because this is a pretty important method. I want you guys to know it properly. Okay, if not, are there any other questions in the exercise before we move on to the next chapter? I'm going to check the Zoom. Okay, could you do one of the finding the relative extrema problems? Okay, yeah, we can do that. Okay, let us do problem 8 to 11, right? Let me just see which problem can be. Okay, let's do problem 11 actually. So exercise 3.4.11, finding out the relative maximum. So yeah, I've given you a f function from R to cube R, and this is basically x square plus y square plus z square, and then you have s as x, y, z, as my z is greater than or equal to 2 plus x square plus y square. Okay, so S, I can just rewrite this as my g function just to keep the terminologies in sync. So I'm going to write my g of x comma y comma z as z minus 2 minus x square minus y square. Just rewriting it. Okay. So yeah, the first thing is like we need to find out. We use the relation my delta f is lambda times delta g. So delta f from the equation, as you can see, if I try to find out the gradient of this, it's 2x, 2y, 2z is some lambda times delta g. Delta g is minus 2x minus 2y and then 1. So if you try to solve these set of equations, let's see, 2x is equal to minus 2 lambda x, 2y is equal to minus 2 lambda y, 2z is equal to 1. So from this, I can have like my lambda is -1. I get the same thing. And then my z is equal to half. Okay. My z is equal to, sorry, my z is equal to lambda. Sorry. Like my z is equal to 2z is equal to lambda. So I get 2z is equal to -1. And then my z is equal to -half. Is that correct? 2x equal to -2 lambda x. So I'm cancelling 2x into x here. Lambda is equal to -1 here. And I get the same thing. And then substitute -1. Z is equal to -half. Okay. Okay. Now we know z value. We know lambda value. So the other relation that we have is our constraint relation, which is z is greater than 2 plus x squared plus y squared. So my z value is like -half is greater than 2 plus x squared plus y squared. Okay. From this, I'm gonna get this z minus 2. So I'm gonna get x squared plus y squared is less than or equal to, you take that. So I'm gonna get it as -5/2. So as you can see, like there is probably no values, because this is like sum of squares. It's always going to be positive, and you won't get any points. Let me see if I made any mistake here. Delta f is lambda times delta g. So I get 2x to y 2z. Lambda times this. Let's see if there is any other point that you're missing. 2x is equal to -2 lambda x. 2y is equal to this. So my lambda is -1. Here my lambda is again -1. And if I substitute lambda equal to -1, I get z equal to -half. Z is equal to 2 plus this. Did I write the constraint wrong or something? Do you guys see anything wrong here? I need to check on this question. Am I making anything wrong? Okay, there is one thing that I'm not considering, the case where probably my x is 0 here. So if I take this equation, I'm going to get 2x is equal to -2 lambda x. So if I just bring it to this side, I get 2x into 1 plus lambda equal to 0. So here either my x can be 0 or my lambda is -1. So if I take the lambda equal to -1 case, I'm actually not getting anything. So I'm going to take the case where my x is equal to 0. So let's take the case when x equal to 0. Lambda equal to -1, we already did that, and we don't get any equation where my sum of squares is actually less than a negative number. This is not even possible. So I'm going to take the case when x equal to 0. When x is equal to 0, let's see from this x is equal to 0. The other, similarly, if I take this equation where I have my 2y is equal to -2 lambda times y, I'm going to bring it this side to lambda into 1 plus lambda equal to 0. So here my y can be 0 or lambda is minus 1. We already saw this is not the case possible. So y is equal to 0, x is equal to 0. And then let's see the final equation. So we have 2z is equal to lambda. That is one equation. The other is the constraint equation that we have. So this is the constraint equation. So which is constraint equation is my z is equal to 2 plus x squared plus y squared. Now, since I know x is equal to 0, y equal to 0, my z is 2. So the point that I'm looking for is like 0, 0, 2 is my critical point. So let's see the value of this function at 0, 0, 2. What is the function that we have? So x squared plus y squared plus z squared. So that's going to be 0 plus 0 plus 4, which is 4. Okay. Now, as you can see, this is like a sum of squares kind of equation. So this is always like an increasing function. Okay. And I'm also having my z is greater than 2 plus x squared plus y squared. So my z value is also like, it's going to be more and more, like according to this constraint. So this is definitely like an increasing function that I'm going to get. Um, so since this is an increasing function, like this is the lower bound of it. So the minimum value of this function is like 4, which is the lower bound. And I'm going to call this as the absolute minimum of this function. And maximum, there is no maximum because it's like an increasing function. It tends to infinity. So like you don't have an actual, maximum where it gets saturates, but there is a clear minima and the value of it is 4. Okay, any doubts in this question? We just took two cases like of solving these equations. So we just, I did not consider the case where my x actually was 0 initially. So it can either be 0 or lambda is minus 1. When I take lambda as minus 1, I get a relation where it doesn't even make sense mathematically. So I just, stick with taking x as 0, y as 0, and then using the constraint equation, I get z equal to 2. I get my critical point. So once I find out the critical point, I find out what's the value of my function at that point, and then figure out it's a minimum because my given function is like a sum of squares kind of function, which is always an increasing kind of function. Any doubts in this question? I'm gonna check the chat. Okay, yeah, that's pretty much how you need to solve these extrema kind of questions. Very similar, as you can see, it's just the same method. Just taking all these corner cases, finding out this x equal, like figuring out these might be the tricky ones. Yeah, when you end up something like this, you clearly know that there's something wrong. Like you're not considering some other case. So that's when you have to go back and see what you made wrong. Okay, I think we have probably solved most of the problems, like similar problems in this exercise. That is all the different problems that I can see. We have taken a look at. Yeah, any other doubts before we move on to the next exercise? The next few chapters is going to be like, proper integration kind of, exercises. So just get pretty, um, familiar with the differentiation and integration of basic equations, formulas, and all that, because you would need them extensively when solving these questions. Okay, if there are no more doubts, let's actually move on to the next chapter. The next chapter is chapter 4. And the first topic that we have is, finding out whether the path is regular, finding out the velocity, acceleration, some physics kind of stuff we have here. Pretty interesting. It'll be good solving these questions. So let's see, like the question 11 is like, determine if a path is regular or not. So let me just bring out the definition of a regular path. So regular path is like a differentiable path. C is said to be regular at t equal to t naught if my first derivative c dash of t naught is not equal to 0. So essentially, they can give you any c of t, and then if you just find out the first derivative, that is c dash of t, and just substitute the point they're asking for, and if it doesn't turn out to be, if it turns out to be a non-zero value, then that path is said to be regular. So I'm just going to do a part in this, which is 4.1.11. B and C, you guys can do it. My C of t is cos t, sin t, and then t. So I'm going to find what is C dash of t, which is minus sin t, cos t, and 1. And yeah, like this doesn't seem to look like a zero vector. So I'm going to say that my C of t is a regular path. And let me do B also. And B is C of t is t cube, t power 5 cos t. C dash of t is 3d square 5t power 4, and cos t is minus sin t. So this, as you can see, if I just substitute, say at t equal to 0, I'm going to get this as 0, this as 0, and my sign is also 0. So it becomes like a 0 vector. So since it becomes like a 0 vector, my c dash of t is not always like non-zero for all values. So because of this, my c of t path is not a regular path. If you take the a path, like I can substitute pi, I can substitute anything, but there is always this one constant here as the third coordinate, which will never make it a 0 vector. So because of that, I can clearly say that it's a regular path. See, I leave it to you guys. You can try it out. Okay, question 12 and 13, pretty similar. I'm going to, try question 13 and leave question 12 to you guys. Very, very similar concepts of velocity and acceleration. Okay, one second. Before that, I think initially someone had asked a set of questions. Let me check. What is that? Okay, it is in 4.2. 4.1 as well. Yeah. I'll solve question 13. 4.1.13. So they're given the acceleration, initial velocity, and initial position of a particle at a time. So a of t is minus 2, sorry, just 2, 2 minus 6 minus 4. My initial velocity at time t equal to 0 is minus 5, 1, 3. And the coordinate of my position is 6 minus 2 and 1. Okay. So I'm just going to write this Newton set of equations, Newton laws of equation, like just for remembering. So I have my final velocity v is equal to u plus at. U is my initial velocity, a is my acceleration. My distance s is ut plus half at square. And then v square minus u square is 2as. So with the help of these equations, I'm going to use it to derive some other equations. So my acceleration as a part of time, it's given as a constant acceleration. So from this, I can write down what is my velocity. So my acceleration is given. I'm going to try to find out what is my velocity. So my v of t is u plus at. So let the initial position be like some c1. Okay, it's going to be some c1 plus a into t. A is like 2 into the time. My next one is going to be c2 plus a into t, which is minus 6. So c2 minus 60. And then the third point is going to be c3 minus 40. So my velocity as a function of time, I've got it, except that I need to find out what's the values of the c1, c and my c1, c2, and c3. There are like some kind of constants, and they are basically the velocity at time t equal to 0, because my u is my initial velocity, which is at time t equal to 0. So good for us, they've already given us what is the velocity at time t equal to 0. So whatever they given here is basically c1, c2, c3. So my c1 is minus 5, c2 is 1, and then c3 is 3. So if I use these in this equation, I can rewrite my v of t as minus 5 plus 2t, 1 minus 60, and then 3 minus 40. Okay. So we have the velocity as a function of time, acceleration as a function of time is given in your question. So the next step is finding out what is our distance as a function of time. So distance, they're given us the distance at time t equal to 0. So from this, I can find out what is my this r of t equation by using my second Newton's law. So this ut is my initial distance. I am going to call it as some other constant. Use the acceleration and the time that I have at that point. So my r of t is some constant k1, which is ut plus. Sorry, this is my initial distance. This is my k1 plus. Let's see what is u into t. So my initial velocity seems to be minus 5. So this is minus 5 into t, which is ut, which is minus 5t plus half at square. So what is my a initial acceleration, which is 2. So half into 2 into t square, which is just t square. So this is my first coordinate. Similarly, if I just make use of the same logic, I'm going to get the other coordinates as k2 plus t minus 3t square, and then k3 plus 3t minus 2t square. Okay, this is my r of t set of equations, but I need to find out what is k1, k2, and k3. Again, that's given in the question. These are k1, k2, k3, and this is c1, c2, c3. So k1 is 6, k2 is minus 2, k3 is 1. So substituting these values, I get my r of t as t square minus 5t plus 6 minus 3t square plus t minus 2 minus 2t square plus 3t plus 1. This is my final r of t equation. Now let's go back to the question. So in the question, they're given the particle's trajectory intersects the YZ plane exactly twice. So YZ plane means it is a plane where my first coordinate is always 0. So that means this term is going to be 0. So t square minus 5t plus 6 is 0. So t minus 3, t minus 2 equal to 0. So t is either equal to 2 comma 3. So these are the 2 points. Let's try to find out what's the coordinates. For t equal to 2, my r of t, let's see what's the value. My r of 2 is 0. First term is going to be 0. Second term, if I substitute my t equal to 2, I'm going to get it as 4 minus 12 plus 2 minus 2. So it's minus 12. Here, if I substitute t equal to 2, it's going to be minus 8 plus 6, which is minus 2 plus 1, which is minus 1. So this is one coordinate. They're asking us to find out 2 coordinates. So at t equal to 3, let's see what is r of 3. R of 3 is 0. T equal to 3 is 9 minus 27 plus 3 is minus 24 minus 2 minus 26. And then here at t equal to 3, it's going to be 9 minus 18 plus 9. which is -9 plus 1, which is -8. So these are the two coordinates at which these are the two intersection points with the YZ plane, and by if you follow this particular trajectory or the path. Any doubts in this equation? Sorry, in this question, like we just make use of our good old Newton's laws of equation, figure out few points, few velocities, and then come back. Question 12, very similar. Use the same approach, you'll get some answer. So very similar. I don't think there's anything in this exercise though. Anything else? I'm gonna check the Zoom if there are any doubts. Okay, there is nothing. Okay, if there are no doubts, we should probably go to the next exercise, which is the arc length. So we'll probably just solve like one or two questions. We can take up the other questions in my next session. But yeah, like I'll try to introduce you guys to how to find out the arc length so that you can give all the questions, all the homework problems a try, and then come back on Wednesday with any doubts. So let's first let me define what's an arc length. So arc length is if you consider C as a path. So arc length is basically the length of path C over or like on a particular interval a less than tau less than b. It is just denoted as my length is integral from a to b modulus of my c dash of tau d tau. So you're just trying to find out the velocity, kind of, c dash of tau, finding out the modulus of it, which becomes the speed. And then you're, integrating that kind of speed over a particular, path from interval A to B that's given in your question. That's basically your arc length. And let's solve like one or two problems you get so that you get, how to solve, get the arc length. Let's solve the first problem. So here my C of t is 2 cos t, 2 sin t, and then t, and the interval that's given is from 0 to 2 pi. So let's find out what is c dash of t, which is minus 2 sin t, 2 cos t, and then 1. Let's try to find out what is the modulus of this, which is 4 sin square t plus 4 cos square t plus 1. I can simplify this as 4 plus 1, which is root 5. So my arc length is integral from 0 to 2 pi root 5 times dt. So which is 2 pi into root 5. That's all. This is your arc length. I can solve the next problem as well. We'll just wrap it up with one more problem. So the next problem is 4.2.2, which is AC of t is 1 3d square t cube, and the interval is 0 to t to 1. So my c dash of t
is that the square root of 6 plus 1?
It is 4 plus 1.
Oh, 4 plus 1.
So c dash of t is 0, 60 3d square. So if I try to find out what's the modulus of this, going to be 0 plus 36t squared plus 9t power 4. So I'm going to take 9 common outside. So it's going to be 3 root of t square plus 4, and then another t outside. 3t into t squared by 4. Okay. So this is what I have. So my length is going to be integral from 0 to 1. That's the interval. Modulus of this, which is 3t into root of t squared plus 4 times dt. So let's see how we can integrate this. I'll take 3 outside. Integral from 0 to 1 t times root square of t plus 4 dt. So let me take some q as some t square plus 4. So my dq is 2t dt, or t dt is dq by 2. So if you substitute this, I'm using the method of substitution. So my q at when t equal to 0, my q is 4. And when t equal to 1, my q is going to be 5. T dt is dq by 2. And then whatever is there inside the root is my q. So if I just have, this is 3 by 2 integral from 0 to 4 to 5, root of q dq. So 3 by 2. So this is basically root of q. I can just write it as q power half. So integral of x power n is, I'm using that formula. So this q power 3 by 2 by 3 by 2 at the intervals 4 to 5. This 3 by 2 and this 3 by 2 gets cancelled. So all I have is 5 power 3 by 2 minus 4 power 3 by 2. Leave it as 5 power 3 by 2 minus 4 power 3 by 2 is 4 cube is 64, and then the square root of 64 is 8. So this is your answer. Basic integration here and there, just making use of a few techniques which we know integration to solve. That's all. Any doubts in this question?
Under the c prime of t equals the square root, when you wrote that, scroll up. Okay, is that, what is that? Is that 31 t squared or
36? Like
36?
I'm just like squaring 60. That's all.
Okay, thanks.
Okay.